Notes. You guys just got those?
Sometimes I just think about
And we'll get Diane. It's not really looking. Diane, go read for us.
Draw a scatter plot for a set of ordered pairs. Use the correlation coefficient. Test the hypothesis H naught V equals.
It's rho. Yeah, so it's rho. It's a weird P. It's a rho. It's actually a Greek letter R. It's a rho. So it's like a little curly. It goes around like this. So let me show you guys. It kind of goes like this. One fell swoop like that. Okay? It's not the same as P. P has a little thing. It's stripping down. It has this little thing up here, right? It doesn't have that. It's just like one little kind of like that. Okay? And it's called rho. R-H-O, rho is its name. Okay, keep going.
Compute the equation of the regression.
Good. All right. So Simran is volunteered. Go ahead and read, Simran.
In addition to hypothesis testing and confidence intervals, inferential statistics involves determining whether a relationship between two or more numerical or quantitative variables exists.
Right. Now we're trying to figure out this chapter whether there's a relationship between two or more variables. Andrew, go ahead and read.
Regression describes the relationship between
Whoa, wait. Start from the beginning.
correlation determines if a linear relationship between variables exists. Regression describes the relationship between variables that is positive or negative, linear or non-linear.
Great. Rachel?
The purpose of this chapter is to answer these questions to consider. 1. Are two or more variables related? 2. If so, what is the strength of the relationship? 3. What kind of relationship exists? 4. What kind of predictions can be made from the relationship?
Miguel?
Which one was it?
Read?
You want to start from the top? Or the
Yes, from the top.
introduction. Are two or more variables related? If so, what is the strength of the relationship? You know, link that is something. To answer these two questions, statisticians use the correlation coefficient, a numerical measure to determine whether two or more variables are related, and to determine the strength of the relationship between or among variables.
Yeah, one of my students, I think, tried to pay me a compliment. She said, you know, I hardly ever fall asleep in your class. So, hardly. Yes, try to stay focused here.
Always someone from the night class.
Yeah, maybe. It might have been. I don't know. I'm not really sure. Embriel, go ahead.
What type of relationship exists? There are two types of relationships, simple and multiple. In a simple relationship, there are two variables, an independent variable, predictor variable, and dependent variable, response variable.
Do you guys remember that from chapter 1 or 2 where we had our X variable, our independent variable, the one we can mess with, the one we can control, and the dependent variable, that was the y-axis. That's the one that depends upon whatever happens with the X variable, the one that we control. Right, so there's one we can kind of control. That's our X independent, and that we're saying that causes something theoretically with the Y in theory. Keep going.
In a multiple relationship, there are two or more independent variables that are used to predict one dependent variable.
Great. Jessica?
What kind of predictions can be made from the relationship? Predictions are made daily in all areas. Examples include weather forecasting, stock market analysis, sales predictions, crop predictions, gasoline price predictions, and sports predictions. Some predictions are more accurate than others due to the strength of the relationship. That is, the stronger of the relationship is between variables, the more accurate the prediction is.
Great. Nirvana? Read.
A scatter plot is a graph of the ordered pairs x and y of numbers consisting of the independent variable x and the dependent variable.
Great. So here's an example. So here is some data, right? Cars and for a car company and the revenue. Which one do you think you can control more? The cars you have or the revenue you get?
Cars.
Cars you have. So this is our X value. Everybody follow that? And then our Y is the revenue. They're two different variables. They're not the same variable, right? Like when we have our dependent samples, right, the heights of presidents and their opponents, those are both heights. These are two different things. Cars and revenue, two completely different things. We're seeing those two different things affect each other. So these are our X's, those are our Y's. So we would draw a axis along the X and we would label it what?
Cars.
Cars, right? And then we draw an X along the Y-axis, and we label that what? Revenue. And what does the X have to go from blank to blank? Yeah, at least 8.5 to 63. Everybody see how you have to cover that? So maybe you go like, 5, 10, 50, I don't know. Maybe I'd go 0, 10, 20, 30, 40, 50, 60, 70. I might do that. The Y's, you guys remember that whole misleading graphs stuff? The Y's, those are the dependent, they should always start at 0. So that one's a little bit different. You should always start at 0 with the Y's, because that's your results, in a sense. So here is, let's take a look at this one here. This would be 63.0, 7.0. That would be 1 point. And that's this point right here. You see it, 63.0, 7. That's that point. These are all so point. And then see how they label it cars and revenue over here? Good. And they kind of just put in their things. This is a positive relationship. See how it's kind of going up-ish? Great. You guys do a scatter plot for this one. Absences and final grades. Which one can you control more? The number of absences you have or the final grade? Absences, so that should be your X. Your X has to at least go from what to what? 2 to 15. Everybody, eyes up here for a second, guys. 2 to 15. So it means you should probably go 0, 5, 10, 15 along the bottom along the X-axis. Your Y-axis, you should go from 0 to 100, because that's your final grade. So you should always kind of start with 0. Or at least 0 to, what's the highest grade there? 90. So at least 0 to 90. So maybe you go 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 for your Y-axis. All right, so go ahead and make that scatter plot.